Okay. I like to walk, so I'm going to go up and down like 25 different times. Today, I want to tell you a story. This is the story of how I used my knowledge about cloud and how cloud architectures are built to own one of the networks that I was pen testing. So the first vulnerability that I found in this story is a very simple one. I'm sure that everyone here already found this vulnerability somewhere. It's an HTTP request proxy vulnerability. That means that I perform an HTTP request to the target URL with some specially crafted URL as a parameter, and this happens, all right? I'm here, I perform a request to this target application, and it's routed to HTTP bin. The response goes back there, and it goes back to me, all right? Very simple. So I found this vulnerability. I was trying to identify and pen test and exploit all the vulnerabilities in that application, in that infrastructure. So I said, well, what if this is, and yep, this is me. What if this is hosted in Amazon? I sent an HTTP request, a special one, with this URL, and got this response. And I was really, really happy. And most of my talk is going to try to explain to you why I was so happy. All right, let's see. First, you guys need to understand what instance metadata is. When you start any instance, any EC2 instance in Amazon, that's a server, basically. When you start a server in Amazon, Amazon attaches an instance metadata to that instance. That means that it will attach a very small, minimalistic web server which provides information to that instance. So, for example, if I'm a developer and I want to know the ID of that instance where my code is running, I can go to the instance metadata and ask that information from there. So I perform, as a developer, I would perform an HTTP request to this URL with some parameter there, some path there, and I could get the instance type, for example, how many cores I have, how much memory, and so on. I could get also from the instance metadata the AMI ID. That means that I can get the operating system, the private IP address, and many other things which live in that metadata, which is only accessible from that instance, all right? Each instance has a different metadata. In this case, and because of the vulnerability that I previously showed, we, from the internet, can access the metadata for that server, all right? And that's interesting because we are kind of proxying through that application, accessing the metadata, and we're going to extract information from there and try to exploit that information. All right, any questions so far? No? Perfect. So, developers usually access this information using libraries. If you're a Python developer, you're going to use Boto to access the metadata. Boto provides a way in which you can say something like import Boto, Boto get me something from the metadata. And that's a method, and you can call it. And internally, what it does, it will retrieve the information from that web server. Because I wanted to do that, and I didn't want to re-implement all the process of knowing the different paths inside the web server for retrieving the metadata. I created a wrapper around Boto, which is going to capture all of those HTTP requests which are made to the metadata, and instead of performing them locally, they are going to be sent through the vulnerability. So let me explain here. In this case, we see that the mangle function is a function that's going to be running on my workstation. All of the HTTP requests that would go to the instance metadata server are going to be trapped by the mangle function, and then I do this. I say, all right, this is the vulnerable URL. I'm going to take the original URL, which is going to look like 169.something.something. We have the mangle URL. We perform a request to that, and we do some error checking. This ends up with requests being made from, this is a tool that I developed. The requests that are made look like this, all right? Boto thinks that it's accessing the metadata from the local server, but actually it's being trapped. Those requests are being trapped with a trick in Python, which is called monkey patching, and they are sent through this vulnerability. All right, so I had the vulnerability. I had the HTTP proxy vulnerability. I knew I was able to access the instance metadata. And I wrote a tool. I wrote Nimbostratus in order to dump that information or dump all the information that's available in the instance metadata. And using that trick that I showed you before, this is how it looks. You need to dump the EC2 metadata using this mangle function, and it's going to tell you the different information from this instance. This is interesting information. You have the type of the instance, which means that like how many cores, memory, and so on. This, if you search it online, it's going to tell you that the instance is running Ubuntu 12. The security groups, or the names of the security groups, for the guys that haven't played with Amazon, and I actually recommend that you play with Amazon for a while, it's really fun. The security group is basically a firewall which Amazon applies to each of the EC2 instances, or RDS, or different types of services can be secured using security groups. All right, and some other information is retrieved using dump EC2 metadata. One of the informations that's retrieved, and we see that here, is something called user data. User data is something that lives in the instance metadata, and it's used to configure the instance. Let me explain a little bit more. Let's say that you are on an architecture, you are on the cloud, and you have a load balancer, and you have servers behind that load balancer, which are going to be turned on or turned off based on load. So maybe at 3 a.m., nobody's visiting my site, so most of the servers, they're going to be killed. During the day, I have more load, and I need more servers to handle that load. Perfect. So when one of those servers starts, it needs to get the latest version from the application that it needs to run. It needs to configure some parameters in order to be ready for handling requests that come from the load balancer. That configuration process can be done in various different ways, but the recommended one from Amazon is to use user data. User data is nothing more than a script which you are going to attach to an instance. And it's something like this. You say, when this instance starts, run this user data. When this instance starts, run this bash script. All right? So each time it starts, it will run the bash script. Great. Perfect. And the security implications of user data have been known, but nobody is doing much about it. In our case, we dumped the user data, and as I said, it was used to configure the instance. In this case, configuring the instance meant download the source code for the application that's going to be running in this server and update it to the latest version, install the requirements, and some other stuff, right? The good thing is that in order to download that source code, you need to have keys. That source code usually is in a private repository. You need those keys, and usually those keys, if that server hasn't been configured yet, need to be somewhere, and that somewhere is the user data. All right? In this case, it was in the user data. So I had the repository, I had the deploy private key, and the deploy public key. I had everything, all right? I had unrestricted access to the source code repository. I was able to download all the source code into my laptop, analyze it, and continue from there. But that's kind of old school. That's what I would do every day, and it's not fun at all. So I continued with the path of cloud applications consume cloud services. Why do people use the cloud? People use the cloud because they want to consume the services which are available. So for example, if I'm building something like Instagram, I want to consume S3, I want to consume DynamoDB. And let me explain what that is. If I'm building Instagram, for those who, I don't know, maybe don't use Instagram or don't know what it is, Instagram is basically a storage for images. If you are building an Instagram clone and you're going to be good at doing it, you're going to use S3, for example, for storing images. S3 is a way of, it's an infinite storage, a hard disk that never ever fills. You can store any amount of data in S3, and you can retrieve it easily over the network. And it's a service from Amazon. So this Instagram web server, it's going to store the images here, and it's going to store, for example, the index for the images in a NoSQL database, also provided by Amazon. So cloud applications consume cloud services. If you're building stuff on the cloud, it's because you're going to consume things from the cloud. And in this case, if the web server wants to access S3, it will have credentials to access S3. Those credentials are basically an API key and an API secret key that Amazon provides, right? Those credentials need to be here in the Instagram.com application because access is required to S3 to store the images, load the images, and so on. There are many ways of storing those credentials. You could basically hard-code it into the source code of the application. You could, I don't know, store it somewhere else and retrieve them. Many different things could be done there, but there is a recommended way of doing it, which is called instance profiles. An instance profile is basically a way of, I'm sorry to the camera guy, I'm making you work. I'm walking all the time like this, and you need to move the camera, sorry. So instance profiles are basically a way of assigning credentials to an EC2 instance. So when the instance starts, Amazon is going to take the credentials that you configured, and it's going to apply them to the instance, right? And those credentials then are going to be accessible through the Metadata Server, which is great news because we have access to the Metadata Server because of this vulnerability that I already told you. And if we have access to the Metadata Server, we have access to the instance profile, credentials, and if we have access to those credentials, we can dump those credentials. Yeah, all right. And the next step, once we have those credentials, is what can we do with the credentials? Those credentials are, as we saw before, just like a hash, a unique identifier. And we need to ask Amazon what we can do with those credentials. After asking, there are many ways of asking, depending on the credentials that you have. You can ask politely using the API because you have access to the API that allows you to ask, or you can brute force. You can simply try to access all of the API endpoints with all the API calls, and if you get a 401, you don't get access to that call. If you get something different, then you get access. This tool, Nimbostratus, and the dump permissions part of it implements both. It will brute force the permissions, and it will ask nicely from using the API. In our case, in our test scenario, what I found was that by dumping the permissions, I was able to only perform one action, which was list queues. I had no idea what list queues was. I had no idea which API it was associated with. So after a couple of seconds of Googling, I found that it was related to SQS. And I'm sorry, I'm kind of throwing a lot of new names at you, but it's the way that the Amazon cloud works. If you try to learn Amazon, Amazon cloud, you try to learn it, you need to learn all of this SQS, EC2, RDS. There are a lot of new names. And they are all 3 letters, which don't make any sense. SQS is a queue service. When you want to exchange messages between different parts of the application, you use a queue. And Amazon provides a queue service. So what we know until now is that our target application is accessing a queue. And what we do here is very simple. Using Boto, I highly recommend you to investigate this. Using Boto, we connect to the SQS API. These credentials are the ones that we stole from the instance, are the instance profile credentials. So we are connecting to the SQS API with the same credentials that the instance would be connecting to us. This is great. We are impersonating the instance. We get all the queues that are available to that instance, and we see that there is one called Nimbostratus Celery. We get that queue, we get a message, and we get the body from that message. We are going to read through that message, and we see that the content type is, or there are many different parts, but the most important ones are that the content type is Python serialized, and the routing key is Celery. So those are two key points to notice. Then we try to write a message to the queue. We do it, we create a message, we write it, we have it. Perfect. At this point, we have something that looks like this. We have our front-end web server, which is vulnerable to that HTTP request proxying. We have the SQS queue. We have workers, which are going to consume those messages that are sent to the queue. This is something new that I haven't mentioned before. If you have someone putting messages in a queue, you have someone else consuming those messages, right? If those messages are tasks, usually they are, you say something like, please process this image, and you send it to a queue, and then there are 25 different servers running image processing algorithms, which are going to take the tasks from the queue and do something with them. All right, perfect. So we know that from here, we have access to the SQS. We were able to get messages from it. We were able to write messages from it. And we were able to identify that the way that the front-end web server serializes the messages for sending them to the workers is using something called Celery. We saw that here, all right? If you Google Celery, you're going to find this. Celery is a distributed task queue, which is exactly what I told you before, is a way of, like from one end of the queue, you serialize a task, you throw it into the queue, and someone else from the other side is going to take the task out of the queue, process it, and do something. Celery allows you to do that in a very easy way and with a lot of abstraction. And Celery has a great documentation. One of the sections of the documentation is a section about security. And it says this about serializers. The default pickle serializer is convenient because it supports arbitrary Python objects. The default pickle serializer, Python objects. If we go back here, we see application X Python serializer. All right, so this is the default. The application was installed as the default. Perfect. But for some reasons, but for the same reasons, the pickle serializer is insecure. And there's a link there, all right? And should be avoided whenever clients are untrusted or unauthenticated. Perfect. So it's basically saying that if anyone, is able to write a message to the queue, you shouldn't use serialize, right? That's what it's saying. In our case, and because we got credentials for writing messages to the SQS queue, we are going to be able to do something with that. Let me explain a little bit more about that something. Python has a way of serializing objects, which is called pickle, which is the same that Celery uses. When you serialize an object using pickle, what happens is you dump an object and you get a string, you load a string and you get an object. That's how it works every day. But if you can force an application to load an arbitrary string, you can get an arbitrary string like this one. You can get pickle to execute a command, all right? And that same bug affects Celery, all right? Because Celery is going to go to the queue, take a message, and that message is going to be serialized as a Python pickle. So, and because of that, it's going to try to deserialize it. And in that process, it's going to, if you wrote some specially crafted message, it's going to execute commands. All right, so that's what we are going to do. We are going to send a payload using the Amazon SQS API directly to the SQS, because we have access, because we stole it from the metadata from the server. And when some of the workers, I don't care which worker, takes the task, tries to deserialize it, it's going to execute arbitrary code, right? And that arbitrary code is going to be a reverse shell, which is going to connect back to my laptop. Easy. All right, this is the way it works. It's like very, very easy. It's, once again, the tool that I wrote, Celery pickle exploit, all the credentials in order to be able to write messages to an SQS queue, the queue where I want to write those messages, the region, like the data center, the Amazon data center where that queue lives, and then I'll write my IP address. You run that, you run a netcat on some other console, and you get remote code execution. That's very nice. Something that you need to notice is that we entered through the back door. We kind of bypassed a couple of limitations that in some other cases, in some scenarios, wouldn't have been possible. Let me explain a little bit more about this. If this architecture wouldn't be a cloud architecture, it would be impossible or very difficult for me from the internet to write messages directly to the queue, because usually the queue would be behind a firewall or behind some other protection. In this case, the queue is, if you have the right credentials, accessible from anywhere on the internet, right? It's not limited by some firewall or security group or anything. You cannot limit SQS access using security groups. All right, perfect. So we got remote code execution in the Celery workers, which is great, right? We got information from here, we got some information from the queue, now we have access to the workers. And we never got access to this application. We got access to the source, but never to the server itself. All right, something that I know at this point is that the Celery worker accesses the SQS queue. I know that because they need to get the tasks from the queue and do something with those tasks. So there are various ways of doing that. Those credentials need to be somewhere. They can be hard-coded into the Celery application source, or they can be in an instance profile. In this case, they were hard-coded into some source code that we have there. We got those credentials, and once again, when you get new credentials, you want to know what you can do with those credentials. You run dump permissions on those credentials, the credentials that we have from the Celery worker. And in this case, we have credentials for something called IAM. We still don't know what it is. And something called SQS. SQS, we already know, and it makes sense that the Celery worker can access that queue. IAM, we still don't know. Also, by grepping the source code, we find that we have access, like the Celery worker has access to a MySQL database using the no root username with a password, and this is the host. So we got access, we tried that access, and no important information was found in that database. That database had only logs and stuff like that, nothing important. And something important to notice is that this database is running on something called RDS. RDS is a managed database that Amazon provides. That means that RDS, when you install MySQL in RDS, all you do is tell Amazon to create a new RDS server, and you have a new database. You don't need to install MySQL, you don't need to configure it, you don't need to do anything. You just say, I want MySQL, all right, there you have it, perfect. And when you want to create a backup, you don't have to install any backup tools, or you don't have to worry about anything. You just tell Amazon, please backup that RDS. All right, now it looks like this. From the worker, we know that we can access a MySQL database, and we know that we can access something called IAM. IAM is access management for Amazon Cloud. This basically means that using IAM, you can create users, groups, assign permissions, and stuff like that. Yeah? Regular access management, nothing very surprising. And a user with IAM Star access can manage all of the above. So a user with IAM Star is able to, for example, create a new user and assign some permissions to that user. So that doesn't sound very secure, right? Because I have a user which only has access to creating other users and assigning permissions to other users. That means that I create a different user, I assign all the permissions to that user, and now I'm root for the Amazon Cloud, right? It's a privilege escalation based on a misconfiguration, that misconfiguration is done by the administrator of this Amazon Cloud. All right, and we have a tool for that, create IAM User. Using these access keys, this tool is going to create a random user. It's going to assign all the privilege available to that user and provide us with the access key and the secret key. Once we have that, we are able to access all of the Amazon Web Services without any limitation. That's great. And we test that with this, right? We dump the permissions for the newly created access key and secret key, and we get that we can perform any action on any resource. All right, so we have root for Amazon. What should we do now? What's next? What's missing? And what's missing is the MySQL database. This database, we got access to it using a non-privileged user, but we don't want that. We want to access it with high privileges. We want to get all the information that's stored in that database. And there are two ways in which we can access the database, the MySQL database. The first one is using a MySQL client with the no root credentials. We got those credentials from the Celery workers. Also, and because we know this MySQL database is hosted in RDS, we can access the RDS API and do something with that API. That something is actually very simple. You create a database snapshot, backup of that database. You restore the snapshot in a new instance, and then using RDS, you're able to change the root password for the newly created instance. So if you don't have access one way, you can get it the other way. You clone the database instance, you change the root password, and then you access using a MySQL client, and the new root password, you access the new server. Of course, I wrote a tool for that. Snapshot RDS. You send the access keys, the new password, the RDS database that you want to clone, and the region where that lives. And after a couple of minutes, you have access to all of the information. Yeah, that's simply a demo of me getting access to all the information. And that's me rocking the cloud. Conclusions. So a lot of developers are working on the cloud, and not many of us are working on the cloud. You are going to see that maybe in 3 years, 5 years, all the developers know cloud, and none of us know cloud. So it's going to be difficult. If you don't start now, you are missing out on a lot. They are already using Amazon. They're already using Rackspace. If you don't know about this, study, learn, and it's really, really fun, really interesting. Amazon has a free tier. That means that even though you need to put your credit card, they will give you for 1 year a lot of stuff for free, which you can like create servers and create SQSQs and do a lot of different things for free. Most of the vulnerabilities and misconfigurations that I exploited today can be fixed, but I haven't seen those fixes implemented by the developers. And these misconfigurations are rather common. If you go to a developer that's working on cloud things, and you talk to him about how he's doing credentials, how he's doing permissions and stuff like that, he's doing it the worst way possible, all right? It's very common to see this or worse. This is me. Follow me. And the tool that I showed you is called Nimbostratus. Nimbostratus has two different parts. One of the part is a script that will call Amazon in order to create an infrastructure in Amazon that's vulnerable to all of this. And the other tool, which is what I mostly show to you, is the different tools that are used to exploit those vulnerabilities. So with Nimbostratus, you get both. You get a kind of a hack me cloud, and you get the tools to solve that hack me, all right? And it's open source, it's on GitHub. Send me pull requests, send me code, report issues, whatever. Questions? Yes?
I have one for you. You say that the basis of how you hack your system with the system is that you get the metadata from the local server. Currently, Amazon says most of this data should not be used actually, because it was designed when the IAM and IAMIs were started.
All right.
In full run, the data didn't persist. Right now, you can start an IMI and store the state on a hard drive that when you terminate the instance, it stays there. So there is no point in using the metadata for upload large applications.
All right. What he's saying, to sum up his question, is that usually a recommendation from Amazon is that the metadata should not be used because now you could have persistent disks or persistent storage. That's true. I haven't read that specific documentation or recommendation. We now have persistent disks, but at the same time, you still need a way of upgrading to the latest code. You could have a script on your disk with all the credentials to access the repository or something. which is maybe also a problem. And the creation of those AMIs, I don't like to work like that. When I build different, and we can talk about that later, when I build different architectures on Amazon, I want to have each server to be 100% clean when it starts, and then install everything from scratch. Instead of having specific AMIs already configured in some way, because if you have them already configured in some way, and you need to make a change, it's a little bit more difficult to change it, instead of having the configuration be applied to that vanilla AMI from the beginning. It's a different way of solving it. Yeah? Any other question? Yeah?
Riancho, this seems to me like a pretty wormable bug. Do you have seen something like a warning about this, or is just a new technique, or have you seen something like before?
His question is basically that he believes that this is something that could be turned into a worm. I also think it could be. I haven't seen anything like this written into a worm or anything similar. And I haven't done any massive testing on the internet to know if vulnerabilities like this that allow you to access the instance metadata are very common or not that common. What I did in order to understand if they were common or not was to talk with developers and ask them what they were doing, how they were implementing things, and stuff like that.
Yeah, you talked to Amazon about the recommendations that they talk to your customers?
No, I haven't talked with them because it's not a vulnerability in Amazon, it's how people use Amazon. You can use it in a secure way, or you could use it in an insecure way. They do a very good job with the documentation. They are very good clues also in the user interfaces they have. For example, if you go to the IAM configuration, a pop-up will appear saying, you're connected using the root account. You shouldn't do this. So they are telling you that you shouldn't do this. But developers usually don't pay attention. They click cancel and continue. Yeah?
Thanks.
Other questions? No? All right. Thank you.